So here we are talking about inverted points and the line y equals x being important when you're doing inverted points and inverted functions and that sort of thing. But before we start on inverted functions and reflections and all that sort of thing, I'm going to talk a little bit more about this line y equals x and why it's important in inverting points. So we're starting off with this point here, point A. You can drag it around, and as you drag it around you can see its coordinates change. And then I've got another point here, the inverted point, and I've organised that so that if this point is at, say, at 2, 7, then this point here is at 7, 2. And if this point is at 4, 6, then this point here is at 6, 4. And the same way if you come down here, if it's at 0.42, then this point, the inverted point, is at 2, 4. The inverted just means that the x and the y are swapped over, and that's what we're doing with these inverted functions. You know, it works if you come down here into the negative lands. If you're at 4 minus 2, then over here you're at minus 2, 4. Alright, so that's interesting, and you can see that if you move this line straight up, this point straight up, then this red point is moving straight across. And if you move the point straight, the green point straight across, then you can see that the red point moves straight down. And if you put them in places where the x-coordinate and the y-coordinate are the same, then it sort of makes sense that the inverted point is going to be the same. Now that line where the x-coordinate and the y-coordinates are the same is the line y equals x. So if we put that in, any time that you're on that line, then the points are the same. And so reflections. If you turn your head sort of sideways, so that this blue line here, if you imagine this blue line here is in the same line as the line that goes right between your eyes down the front of your nose, if you turn your head on the side, then you can see that, and then you imagine you're standing at point A looking in this mirror, the point B is going to be straight towards the mirror and the same distance on the other side. So if you move it over here, the point B is straight towards the mirror. In fact, if you do this, you can see the line goes straight towards the mirror, so the line makes a right angle with the mirror, and then it's the same distance on the other side. So you can put that in. You can see that this line, these points, the inverted points, if you tilt your head on the side, you can see that the inverted points are like the same as a reflection would be. So that's why you call it point B is reflected about the point, about this y equals x line. So that's why the y equals x line is important. It just so happens that that's the line that these inverted points are reflected about. So we can use that. We draw a parabola, say, and then we've still got these reflected points, but what we're going to do is force the point A to actually be on the parabola. And so now as you move the point around, it has to stay on the parabola. And you can sort of see what's happening to the point B. It's still reflected in that line, and you can sort of see what it's doing. But if you do this, you right click on this point and you say turn the trace on, then as you move this, then you leave a trace of where that point has been. And you can see that as you move the green point around the parabola, then the red point makes a parabola of its own. And if you turn your head sideways, or you've kept your head turned sideways, then you can sort of see the reflection. So this green, this line here, the black line, is reflected in that line, and it's made that sideways parabola. So what I'm going to do now is just turn off the trace. Oh no, wrong place. So I have to right click on the point and turn the trace off, and I'm just going to click that and turn the graph on so that you can see as I move this around. And I'm doing that because when I move the parabola, if I move the parabola up to here, I find it's easier to see that it's a reflection when it's not crossing the line. You know, it's that one goes that way, and then it's reflected in that line, and this one goes around like that. And so, and you can see as you move the point on the parabola, then the point B, the reflection point, also moves in the sideways parabola. in the reflection. And yeah, and you can move the parabola around and it holds for, put the turning point right on there. Then I've lost the point A. How do I get it back? What I want to do is put it over there, I think, and then I can put that back there, and I can move these points down, and so they're at the same point as they cross the blue line. Again, they're at the same point there. But it's a reflection, and the line y equals x is important because it just so happens that these inverted points are they're in the same position as they would be if they were reflected in this line. Excellent.